Once again, good morning, good afternoon to all of those attending this webinar on improving urban pavement roughness measures to meet customer expectations. Today's webinar is being led by Ed Poppitt from the City of Austin and Chris Newson from AgileAssets. We'll start with Ed. He's our guest speaker who has worked for 34 years at the Public Works Department for the City of Austin, Texas, where he currently serves as consulting engineer for the Infrastructure Management Group at the Office of the City Engineer for the Street and Bridge Operations. He provides general engineering support for streets, bridges, sidewalks, pavement design programs, and criteria and asset management. He also helps the city develop its newly formed asset management office. Over the years at City of Austin, he has designed pavements, street reconstruction and rehabilitations, and has collaborated with pavement and bridge management teams since 1993. He has studied the specific challenges of data collection on city streets and has developed innovative recommendations for improving roughness data quality, which he'll share with us today. So welcome, Ed. Our moderator today is Chris Newson. Chris is an asset management expert with more than 25 years of experience in conducting, managing, and analyzing asset condition surveys to improve roadway performance. Chris has led survey operations for large international consultancies and specialist data collectors. For many years, Chris was the pavement data lead at Highways England, where he was responsible for how pavement data was used throughout the organization. He was responsible for Highway England's pavement management system. Now, as senior consultant at AgileAssets, Chris works with agencies around the world to improve the performance of their transportation network and deliver a higher return on infrastructure investments. Chris will lead the dialogue with Ed, and they will both be available at the end of the presentation to help you with questions. And with that, we'll hand it over to Chris and Ed for the start of the presentation.
Thank you, Nick. Once again, welcome everyone to our webinar, Improving Urban Pavement Roughness Measures to Meet Customer Expectations. So today we'll be learning best practices and hearing recommendations from an agency that has a lot of experience with improving pavement management at the local level. And that's longtime AgileAssets customer, the City of Austin, Texas. I'm very happy to have Ed Poppitt here to share his insights. So today's session will be presented dialogue style. I will introduce key topics or questions, and Ed will speak from his agency's experience and research. So we'll start this session with a brief overview of how city and county streets are unique in comparison to larger highway systems. We'll discuss the importance of data quality and the impact of using ride quality and surface distresses as two ways of evaluating the condition of city or county streets. And we'll show how better data leads to better decisions. We'll also dialogue about the challenges of data collection and hear Ed's recommendations to local agencies for improving pavement roughness measures. And at the end, we'll invite the audience to participate with a real-time poll and audience Q&A. Again, feel free to post your questions anytime in the Q&A panel, and that's Q&A panel rather than the chat panel. So let's dive right in. Ed, let's have a look at some of the things that make city and county pavements different from state or national road networks. What are some of the attributes that make local streets unique?
Thanks, Chris. Managing city and county streets is very different from managing state highways. We typically manage our roadway networks in much smaller segments. Austin uses block segments from intersection to intersection. Residential neighborhoods have much more irregular street configurations compared to highways. And we have different traffic patterns than on highways, of course. There's frequent stops and starts, more traffic congestion to work around, and many more turning motions, and of course, lower speeds. We have different pavement structures and maintenance cycles. There are far more utilities and utility services within the streets, and we have less uniform profiles and cross sections than highways. And there are very vocal public concerns about safety, traffic disruptions, and noise that are very close to us, and we hear about them regularly.
So it seems there's a lot going on that makes managing these types of roads just that much harder. So given the unique attributes of local streets, let's talk about why it's important to have high quality pavement data so we can know the condition of the streets in the network.
Well, we found that city drivers care about comfort on the road a lot more than many other attributes. We know this from citizen feedback through rough or failing streets, speed humps, potholes, and so on. Also, research since the 1950s shows that pavement users are primarily concerned with that ride quality. So it's important to be able to measure ride smoothness.
Yeah, and this is a global theme. Recently in the UK, the government's road monitor, the Office of Road and Rail, undertook a study to determine what a road user wants from road condition. And yeah, a smooth ride was the clear winner in the UK as well.
Thanks, Chris. We do also recognize, though, that it might be a mistake to rely entirely on ride quality as the indicator of health of your pavements, because you don't want to put off preventative maintenance treatments until the ride quality is bad enough for the public to notice that. Thus, we use surface distresses as a leading indicator of pavement condition to select the right treatment. So it's important to have multiple ways to measure road condition so you can get a more accurate assessment of the pavement's structural state, and so you ensure higher quality data collection in the first place.
So tell us more about the types of data you deal with and what the data is good for.
Pavement managers typically make treatment decisions based on the road condition they're able to collect. And so the better the data is, the better the decision making can be, from strategic planning through day-to-day operations. Probably the most common type of street condition data for cities and counties is the surface distress data, which typically measures as many as 12 or more visible surface conditions, such as cracking, rutting, and raveling. And Austin has simplified this a bit by just reducing that down to the surface distress measures collected for us are the 4 major types of cracking: alligator, block, transverse, and longitudinal cracking only. Here you can see examples of different distress data that's collected. There are several types of cracking. There's rutting, raveling, flushing, spot failures, and several others that we're not even showing here. At the network level, pavement managers often collect ride quality data as measured by the International Roughness Index, or IRI, as the most mature, efficient, and cost-effective measure of network-level pavement condition. Unlike many urban agencies, Austin has put a significant emphasis on the importance of measuring the pavement smoothness, because we hear ride quality is possibly the most important thing to our citizens. However, I'll talk about it in a few minutes. Collecting valid IRI measurements in the city does offer some very significant challenges. There are also a few other pavement data types. Agencies with higher speed roadways will often collect surface friction data for safety and risk management, and also structural data such as the pavement thickness and deflection data can also allow for the evaluation of a structural adequacy index. Both of these additional types of measures can be used in decision trees or become part of the composite pavement quality index. The higher quality data your agency has available, the more accurate and repeatable your analysis will be. This leads to better informed decisions when planning and implementing your pavement management strategy. And finally, this results in better long-term outcomes for your agency and happier citizens or constituents. Our citizens expect that we're making well-informed project selections, and the data and systems we use must be able to support reliable, repeatable, consistent decisions to inspire trust and confidence. At the City of Austin, we've worked hard to modernize our pavement management practices, including using advanced performance analysis. The success of our analytics depends on the quality of our data. The consistency and validity are essential. Through robust data analysis, the city and/or county agency can achieve better long-term outcomes. For example, you can maximize the use of your funds, create optimal work plans to apply the right treatments at the right time to get the most for your money, and you can extend the life cycles of your pavement assets and improve your entire road network performance.
And I guess all of this helps you to manage the network in the optimal manner. So having the right data and evidence to back up decisions, how can I put it politely, helps counteract the pressure from non-agency stakeholders to treat the roads for any number of non-scientific reasons, rather than treating the roads that are most in need of maintenance. So tell us more specifically about some of the outcomes you've been able to achieve at the City of Austin as a result of rigorous data analysis.
We've achieved some major improvements for the City of Austin. We've increased our funding as a result of better budget forecasting using the AgileAssets Pavement Analyst solution. Through detailed analysis and projections, the city has justified a 37% increase in preventative maintenance funding. We've gone from 19 million to 26 million over a 3-year period. Also, through more accurate planning and reporting, the city justified a 25% increase in rehabilitation and reconstruction project funding. We moved from $12 million to $15 million per year on average. Overall, the City of Austin was able to increase our pavement funding by an extra $16 million over 3 years. That's because we were able to provide increased visibility to our legislators using accurate data to justify higher funding.
So it would seem having good data and following an evidence-based process gave decision makers the confidence that money was being well spent. And I guess with that confidence, they could see that additional funds were going to provide a good return on investment and led to the budget increases. So Ed, let's get to the nitty-gritty of how you collect data for your network and ways you can improve the quality of your roughness data. So how do you collect your data at the city level?
Yeah, let's talk about distress data first. There are 2 ways to collect distress data. One way is to perform a visual rating. You can train in-house staff to do this work or hire a third-party vendor to provide data collection services. Another way to collect this data is automated data collection using vans with 3D cameras and lasers. Vans collect roadway images, and then the images are analyzed to determine the distress types. Again, you can find third-party service providers that can collect and analyze the data and provide it to your agency in the required format.
And I guess just interrupting, one of the advantages of machine-based systems is they're repeatable. I can recall from my early survey days, I know how difficult it was to get 2 different surveyors to come up with the same results on a visual survey.
Yeah, that consistency is really valuable, and the automated systems have come a long way. Here we see data collection equipment. The first picture is the rear of the van showing high resolution line scan imager and HD camera for right-of-way images. The second picture is the shock mounted rack of computer equipment necessary to digest the vast amount of information streaming in from all of these sensors. And the third picture is the front end of the vehicle showing the laser ret bar, additional cameras, and the GPS antenna on top. What's not visible are the accelerometers and distance measuring instruments in this sophisticated inertial profiling unit. A fully outfitted van can cost up to about $1 million.
So we know that collecting good quality data is often a challenge. Tell us some more about some of the challenges you've encountered at the City of Austin.
Measuring ride quality by IRI is problematic outside the higher speed highway environment with its more uniform geometries. The IRI was originally designed for that higher speed uniform roadway environment, such as highways, interstates, and national motorways. But for urban roadways, with irregular street configurations and highly variable traffic speeds and levels, collecting valid IRI measurements is challenging. Urban traffic flows include a lot of stops and starts because the streets are shorter and have more intersections with traffic controls like signals and signs. These environmental conditions cause the data collection vehicle to have frequent speed changes and irregular speeds. Ride quality or smoothness, as IRI is measured with a profilometer, requires a constant driving speed while you're testing. I should note that there's a legitimate concern that using the ride quality is more of a lagging indicator, especially for pavement deterioration. So ride quality only becomes noticeably worse when the street distresses reach an advanced state, and this leads to more rapid and serious deterioration of the pavement structure. But by then, the cost of treating that pavement to bring it back to an acceptable ride quality is much higher than when the damage mechanisms were just beginning to appear as surface distresses. Therefore, we use a combination of surface distresses and roughness in our decision trees to select the right treatments for Austin. Urban pavements also typically contain numerous utility valves and manhole castings, many of which are not level with the pavement surface. These do cause irregularities in the data collected, and some bumps can be filtered out, but this is not an automatic process that catches all of them, and it's not feasible to eliminate this flaw entirely. Here you can see there are odd-shaped intersections. There's numerous manholes in the streets everywhere, and there are things like paver crosswalks and other specialty paving that can create distortions. In addition, traffic calming devices like speed bumps and drainage features like concrete valley gutters can lead to lower speeds and less reliable data. For these reasons, the city and county transportation agencies need a different approach for using pavement data to get a truer picture of pavement condition, so they can make sound treatment decisions and obtain higher return on their pavement maintenance investments.
Yeah, so as we can see, it's tough to collect high quality data on smaller streets with structural irregularities. Now, something I just want to throw in here. I know there's an argument that items such as manhole covers that can impact the results shouldn't be discounted because, you know, the road user still feels the impacts of these. They still feel the lumps and bumps as they're driving, as they go over the covers. You know, and I know improvement might not be a quick fix, but if we want to be truly customer focused, then should we consider how we can improve ride quality around these areas?
Yes, we've kind of treated it as two separate issues where we try to use the collection of the roughness data on the street area as accurately as we can, and then treat the castings as a separate issue and get them into tolerance by enforcing like a 3/4 inch tolerance to this surface of the street to assure that those castings don't create large bumps. So I think we might want to keep it as a separate issue because it's difficult to get it all perfect at once. And the utilities are a constant adjustment that has to occur as overlays are put on and the street surface changes.
It's a tricky subject dealing with all of the metalwork in the roads. So tell us about your recommendations for improving the quality of collected data in a city or county network.
Sure, we looked into the possible adjustments that could be made, and we found that there are a number of things that can be done to potentially adjust the IRI for the urban environment. One is that the IRI can be adjusted based on the average data collection speed. We found a TRB published study in 2017 for streets where they looked at a speed adjustment, and it seems to have correlated well with the perception of roughness inside the vehicle experienced by the driver. Also, NCHRP just published a report 914 on urban IRIs for this exact reason of everybody having some difficulty translating that highway-based IRI data standard into the urban environment. We also found that there was a possibility of collecting twice as much data to ensure that you had two profiles for the same section to make sure that they match, and that you could potentially average out errors by taking the average of the two scores. Data can be collected each year in the exact same lane and same direction if you track that well. Does involve some additional effort on data maintenance to assure that the vendor knows exactly which lanes were collected previously to do that in the same lane and to get repeatable results. We can also use law enforcement to allow continuous data collection and more constant speed through intersections and congested traffic areas.
Another way to improve data collection is to collect at night to do surveys when traffic flows are lower. I know in a previous role when I was running survey operations, we did all of our urban surveys at night to minimize the impacts of the stop-start and try and get better roughness data. I know the downside of this is that it costs more due to having to pay the staff to work antisocial hours, but on the flip side, productivity does go up. And I know When I was working in the survey company, this was generally cost neutral, so you may be able to negotiate with your provider for night surveys at no additional cost. The other drawback is that any forward-facing imagery collected will be impacted, so this would have to be obtained by other means, and that might mean an additional survey during the day.
Yeah, it's a great suggestion, though, and I think that the efficiencies gained and the repeatability of the results, I think, would be quite worth the effort to do that. So, thank you very much. That's a great suggestion. We also found that we could ensure that the equipment was certified to collect data down to lower speeds, which involves assuring that on a known track or known segment, that you could compare the results to assure that that those data collected were valid. This may require development of a new IRI standard, a new standard to be developed so that the road profiling industry can accept that new methodology and apply that equally across all data collected. That would be very desirable. We can mandate the use of high accuracy reference profiler to spot validate data, which again gets back to the certification that the results are valid. We can require additional calibration and certification of the primary profiler at lower speeds, more like the urban environment, and implement QA steps in your pavement management process to check the data, to kind of give a sanity check, to compare results that you expect with what you got, and to maybe ask for data to be recollected in places where it doesn't appear to be reflecting the true street conditions.
Brilliant. Thank you, Ed. So some good points there to help improve the quality of the collected data. This is the end of the presentation part of the webinar, but we'll be having a Q&A session shortly. Before that, though, I'd like to thank Ed. So Ed, thank you. You've given us a lot to think about, the challenges of improving pavement data collection in the urban environment. I think that the key message here is that collecting good data in urban environments can be tricky, but there are ways to improve the quality of the data. I think we also learned that with the right tools in your toolbox, good data leads to good decisions. And this brings the benefits of a well-maintained network, happy road users, and confidence from the budget decision makers that the maintenance budget is being well spent. So on that note, I think I'll hand back to Nick.
We will welcome Chris and Ed back on to answer some Q&A. And I guess, Ed, we'll start with you. We do have a lot of Q&A. We'll go with that. But Ed, we'll start with you. And, have you had a chance to use any of the roughness data improvement techniques that you've suggested?
Yes, we have tried adjusting the scores based on speeds, and using that methodology from that case study has affected some definite trends in the data that look correct. So we think that that's very promising. We'd really like to see a new standard for the urban IRI so that low speeds are accounted for kind of uniformly across the nation. But in the meantime, we probably will try several of those methodologies.
Great, guys. So we do have a ton of questions. Ed, we'll go another one to you. If collecting valid roughness data in the city is so difficult, why do you feel like it's so important to do?
Well, that really goes back to the, satisfying customer expectations, and ultimately, our customers, the citizens of Austin, are the real point to our either meeting or falling short of the community expectations, and being successful or not being successful. If we use just technical measures of success, it satisfies the engineer in us, but ultimately it's the customer and that citizen that needs to be satisfied with the value that the customer, that the citizen is paying in their tax dollars or fees to maintain the streets, or they're going to just be dissatisfied with the level of service they're getting.
Yeah, and I think that is the key thing. The customers are paying for a service with their taxes that they pay. So, if they're paying for a service, they want a good road, and what they feel as they're driving generally is the lumps and the bumps of roughness.
For either Chris or Ed, do you use traffic control when using data collection to achieve constant speed?
Yeah, this is Ed. I can address that. Right now, we have not used law enforcement or any additional help in the data collection process. We've just relied on the vendor to try to do the best they can to select appropriate times and try to stay off peaks and things like that. We think that that is a viable way to help out with the data collection. It's just a bit problematic. We found that using off-duty police officers has its pluses and minuses. They're not always as helpful as you would hope. It's just a kind of a mixed bag. Sometimes you get some folks that are real helpful and sometimes not. And it can be quite expensive. It's not an inexpensive proposition to have off-duty officers. But we feel like that is a thing, a promising aspect that could be used in key areas. We have not gone down that path yet, but it is out there as an additional method we can use.
Yeah, and just adding to that, so back from my survey days, certainly in cities we never use any sort of traffic control to try and help us maximize the readings that we were getting. But the times we did use them were sort of on the motorways, the interstate type of roads, where we were sort of had a specifically collecting, you know, the outside lane, the fast lane, and then we did have a police escort, but that was more for the safety aspect rather than trying to maximum out the quality of data and the amount of data we got.
Great. Again, we got a lot of questions, and we got some good amount of time, so we can get to as many of these as we can. How complicated is it to use multiple types of data in your pavement management decisions?
Well, that's a fun one for the pavement managers. The decision trees can get quite complicated. I think y'all probably recognize that just from the nature of the question, that the more you try to bring in, the more complicated it gets. So our decision trees just for the city of Austin are pretty involved. And that is, one of the conundrums of more data means you got to deal with more data and use it intelligently. So the decision trees do get quite complicated. But that's just the nature of the business. You want to make your decision as intelligent as a pavement expert would. That's what the pavement management system is trying to emulate, an expert. What would you choose if you had everything to think through? And so you do find that it is a very complex decision. There are a lot of factors to take into account. So just carefully set up your decision trees to be as robust as you think they need to be, to weigh in all of the factors that you you want to account for.
Yeah, and I think the thing to add there as well is the cost benefit of collecting all of this extra data to put into a decision tree. You've got to pay for the collection of the data. You've got to pay for the storage of the data. There's also managing the trees and everything like that. So it all comes at a cost. So it's just sort of using the data where you can maximize the benefit from it, and it's not just a case of collecting data for data's sake. So I think that's one of the key things as well.
Is data collection methodology the same in concrete and asphalt pavements?
So certainly in my experience in the UK, where I've done a lot of my surveys, the actual data collection methodology is the same, but it's the algorithms that are used on the data to get different results that differ. Obviously, you get different defects on concrete than you do on blacktop roads. So you're looking for different things. But the actual collection of the data, we've tended to use, one of the survey vehicles with all of the lasers all on it. It's collecting the data. It's just how you use that data is then different. So yeah, Ed, I don't know if you've got anything to add.
Well, yeah, it's kind of a multi-part question in terms of how do you collect the data. As you've implied, there can be some differences in, of course, the actual distresses you're collecting, but then from a roughness perspective, we have so few true concrete pavements right now in our inventory. We only have 1% of our streets are concrete at the surface at this time. We anticipate that's going to go up a lot in the future as we see the incredible value of the durability of concrete pavements. But we haven't developed a separate standard for the cutoff points for the roughness values. So right now we're using the same cutoffs in terms of what's acceptable. So in terms of ride score, we're just saying the same IRI, the same value of roughness is acceptable or unacceptable on each of the classes of streets. We do vary that by classification. Arterials are graded more aggressively than the collector streets, and the residential streets even can be a little bit rougher than both of the arterials and collectors.
Great. Ed, this one is for you. It's kind of a multiple part question. What is the cost to inspect your streets per lane mile? And how does an agency afford to use budget on inspection rather than just resurfacing?
I'm going to have to get back to them on that because our costs, we just got a new contract, and so the costs have varied. But to the answer of the value of the data, we're making decisions about many millions of dollars of investment in our network, and collecting $100,000 or $200,000 worth of data does seem worth it, because in addition to just the maintenance money, we're making capital decisions as well, and that could be that could be $10 million a year or $11 million a year of decisions, and that makes that data every bit worth the investment, rather than just do another lane mile of overlay. That having that data intelligently allow us to apply all of those millions of dollars correctly, the scale is in balance for us, that data is every bit worth the money to correctly invest millions of dollars.
Okay, this is a good one. Chris and Ed, this could be a good way for both of you to jump in. Why are we not collecting, we as in probably the United States, collecting surface friction data compared to Europe and other countries?
Well, I believe that any highway department is collecting the surface friction data. So it's speed based. In the urban environment, we have much lower speeds, so our risk of not collecting friction data is much lower, and we get complaints about slick spots, and so we treat them more as an independent or an individual location. So if there's a slick corner or street segment, we may install guardrail. We may, of course, address the street surface with some kind of surface treatment. But it tends to not be a huge issue at the lower speeds we have in the urban environment. But I believe anybody who has a high-speed roadway, so all highway agencies and counties that have long stretches of faster speed roads, they probably are actually collecting friction data. So I think you just have to be concerned about the speeds in your jurisdiction.
Yep, and just to add, so in the UK and sort of in wider Europe, we do a lot of friction surveys in the urban environment. Now, this is kind of a historical thing, but I think it's just that whole being proactive. So I think in the UK, we tend to like to, not be reacting. If we can stop an accident, stop someone getting hurt, that takes quite a high priority for us. So that's kind of led our philosophy into measuring friction.
Are there other ways, or are there smaller units to use other than a vehicle to be able to measure roughness or rutting?
Yes, there's a wide variety of data collection mechanisms, machinery and devices. There are golf cart sized things. There's the real high accuracy profiles, like a dipstick is just something you're walking with. But the difference is, of course, in the productivity of each of those devices can be quite different as well. So there are a number of different size devices, and some of them are much smaller, scaled down to be used in tighter locations, or just a different level of productivity that's needed that can maybe operate at a slower speed. So there's a huge variety of data collection devices available. So I'm sure anyone out there could find something at a variable size and scale that meets their needs and their productivity needs for just how fast you get around and get all your data collected.
Yep, and I guess the other thing to add in there is the safety aspect. Obviously, if everything is vehicle mounted and driving around, it's traveling at vehicle speeds, and there's little risk to people doing the survey. They're traveling at the same speed as everyone else. If you had a smaller device that's maybe a walk device or something like that, you're then into needing traffic management as well. So I think having it on a vehicle improves the safety of the operation.
Do you think roughness data should be collected separately other than distresses? What is the unit of measure used? And then what is the unit of measure used in distress?
Okay, no, if you can collect all that data at the same time, if you can have the expert user in the van that's, visually being able to see distresses that they need to count visually, and have the cameras taking the pictures for any automated distress data that can be evaluated by the computer visually at the same time as you're using your accelerometers to collect the profile data, there's no reason not to collect it together. You want to be as efficient as you can. That, of course, gets back to the cost of the data collection. The more efficient you can be with that data collection, the more you can make use of that in a cost-effective manner to make good decisions.
Yep, and just adding, I guess the main cost of a survey is the cost of staff. So if they're just collecting IRI or collecting, automated distresses as well, it shouldn't really cost that much more, because the staff time is the biggest part of the cost of that.
Speaking of cost, we did have a cost question here. Could you explain or tell us what would be the financial KPIs obtained in order to justify a budget increase authorized by legislators?
That's a pretty tricky question, because every decision-making body has its own way of looking at things and weighing out the decisions. So unfortunately, I don't think there's a simple answer to that question at all. It's a good question, because you really do have to link the value of what you're doing to the decisions you're making, the risks you're making, the consequences of the actions you're going to take. I mean, that's a real nature of pushing beyond just simple asset management and pavement management into the true asset management in holistically. But it's a very complex decision, and there's not one right answer. Each agency makes its decisions, and their policymakers think about things differently. But it is important. It's a great question that leads you to think about what is the linkage between the decisions you're making, the value of those decisions, the outcome you're going to get, and how are you deciding about those choices, and telling folks about the whole value proposition and risk that they're taking and the outcomes they're going to get. So it's a great question, but I don't have a simple answer for that, unfortunately.
Yeah, and just adding to that, I think the key is being able to forecast what's going to happen. So with your decision trees and your deterioration models in your pavement management system, you can give the decision makers, okay, if you keep my budget the same, the condition of the network is going to be this. If you give me less money, the condition of the network is going to get worse by this amount. If you give me more money, then the condition of the network will improve. And giving the decision makers those options, they can then make that decision by having the evidence and the data behind it.
How regularly do you update your data? Is this a monthly thing, a quarterly thing, an annually thing?
Yes, I can say that we actually backed off on our data collection cycle, and it's not necessarily the most ideal thing. It's just we found for an affordability, we were collecting data every other year on half of the network. So we were basically on a 2-year cycle, which is much longer than the question was implying. We've now backed off to a 3-year cycle, so we're collecting a third of the network each year. That has some pluses and minuses. Of course, it lowers the cost per year, but it means that we don't have a data point on any particular street but once every 3 years. That's enough to do some, good modeling and prediction on. But, the ideal would probably be, depending upon how aggressively your network is changing, would be once a year, start there, and then see if you can get away with less often. We have backed off on ours, but again, it's a question of how your network is changing, how fast it's changing, and what kind of questions you have to answer, and how accurate that data is going to be when somebody asks and then looks at the street and compares the answers.
Yep, and I think that's the key thing, is how accurate is the data for the decision you need to make. So I'm going to throw in a UK sort of example here. So the motorway interstate network, that's done on an annual basis, all lanes. If we then come down a level, that's done in the main lane in both directions each year, and then you start coming down the levels, and when you get to the little sort of very, very tiny sort of urban housing estate streets, that's done on sort of like a 4-year cycle. So it's really, what data do you need to make the decisions, and what's the risk of not having accurate, up-to-date data will impact the survey frequency.
Following up on more collecting data, does the city of Austin, do you collect distress data on just sample units or in 100% of the area?
It's a sampling, but it's 100% of the length of the street in one measured lane path. So it's just a 10-foot swath of every street section. And on the wider streets or divided streets, we do both road beds, one pass on each way. Most of the network, we just have one pass. On arterial streets, we tend to have two lane miles collected for those streets. So it is a sampling, but it is the entire length of each street.
Awesome. And we have time for one more question before we wrap up. And this will be for Ed. Does the city of Austin currently require the vendor to certify the inertial profiler?
Absolutely. Yes, we really feel that's quite important to tell us that within a year they've taken it to one of the main test sites and can show us the validation of that device. We have insisted on that from the beginning, and we think that's quite important. Absolutely, yes.
Ed, Chris, thank you. Anything else to add before we wrap up for the day?
No, it's great questions. And I think from those questions, I can tell folks are really putting a lot of thought into what they're doing. And it's great to see. I really appreciate it. And Chris, thank you for your additional comments. They've been great.
Yeah, the email on the screen here, if there's any questions, there are a bunch of open ones, but we're about out of time. So if you do have some questions that we didn't get to, feel free to email us at info@agileassets.com. Chris will answer them. Maybe we can get Ed to answer some of these questions as well. And some of our other experts at Agile Assets can help answer a lot of these questions. And be on the lookout for other webinar presentations that we're going to be having in the next handful of months. Once again, thank you to Ed Poppitt from the city of Austin, Chris Newson from our EMEA branch in London for answering our questions and delivering this amazing presentation today. And thank you everyone for joining the presentation. I'm Nick Frank, and we will see you for our next webinar presentation presented by Agile Assets. And again, if you have any questions, head on over to info@agileassets.com. Thanks, everybody.